Hello everyone and welcome once again to this concluding video or interaction on this triangles class 10th 6.5 exercise second part. We are doing the application based questions of Pythagoras theorem in this exercise. So let's take the next question. Okay, so question number 9. A ladder 10-meter long reaches a window 8 meter above the ground. Find the distance of the foot of the ladder from the base of the wall. It's a very important point we should note here that whenever you get a geometrical question based on geometry, we must draw a figure wherever it is possible, whenever it is possible. The figure is must in geometrical questions. Out of that figure, we'll extract the required shape, whether it is a triangle or quadrilateral or parallelogram or circle, whatever. Okay, so let's draw the figure, try to make the figure out of this situation here. Figure comes out to be like this. This is ladder 10-meter long and here is window 8 meter above the ground. Okay, we need to find this. So this is a right triangle with two sides hypotenuse and perpendicular given to us. We need to find the base AB. Okay, so let AC be the wall and BC be the ladder. We need to find AB. In triangle, right triangle, that is ABC, we need to find AB. We apply Pythagoras theorem to the triangle. BC square is equal to AB square plus AC square, but we need to find AB. So AB square comes out to be BC square minus AC square. We replace BC by 10 and AC by 8 and solve them, simplify them. You get AB square is equal to 36, or AB comes out to be under root 36, that is 6. Means the distance between the foot of the ladder and the base of the wall is 6 meter. Okay, so point you should note here that whenever you get a geometrical question, you must draw figure first. It will help us in solving the question, in understanding the question, and apply the relevant theorem property formula in that particular question. Understood? So let's take next question. That is question number. So as we discussed earlier, that we are taking selective questions in the this exercise, selective question of the exercise. Okay, so question number 11 we are taking now. An airplane leaves an airport and flies due north at a speed of 1000 km/h. At the same time, another airplane leaves the same airport and flies due west at a speed of 1200 km/h. How far apart will be the two planes after 1.5 hours? East, west, north, south. Okay, so one plane leaves towards north this way. Okay, and other plane at the same time leaves towards the west, right? So distance covered by this plane will be 1000 into 3 upon 2, 1 and 1 upon 2. When we convert this to the improper fraction, it comes out to 3 upon 2. Okay, so distance covered by the plane towards north is 1000 into 3 upon 2, that is 1500 kilometer. So this distance is 1500 kilometer, and similarly distance covered by the plane towards west is speed is 1200 kilometer per hour. So in 1.5 hour it will cover 1200 into 3 upon 2, that is 1800 kilometer. Towards west it is 1800 kilometer. Okay, so see the structure or the figure we are getting here is, if we need to find this distance from here to here. So this comes out again a triangle, right triangle. We need to find h of this right triangle, and h by Pythagoras theorem we know that it is under root b square plus b square. So let's apply this. Distance between the planes is equal to, here b square is this and plus b square whole under root. On simplifying it, it comes out to be this, right? Now see, it's a large number, okay? So we can calculate it separately if we know how to calculate the how to find the square root of a number. If not, this is leave these four zeros. Try to consider on this number 549. This is not a perfect square, okay? So in case of imperfect square numbers or not perfect square numbers, we split the number in as a product of two numbers. Out of those two numbers, one is perfect square, okay? So try to split 549. If we work on this, as I keep saying that drilling is the key to success in mathematics, right? It will sharpen our skills. So 549 can be written as 61 into 9, right? 61 into 9. And these four zeros will be here. Four zeros, square rooting, square root of four zeros is two zeros, means 40 to the number, not alone. So this comes out to 90,000 into 61. Square root of 90,000 comes out to be 361 as it is under root 61. So distance between the plane comes out to be 300 into under root 61 kilometer, right? So next question. Again, two poles of height 6 meter and 11 meter stands on a plain ground. If the distance between the feet of the pole is 12 meter, find the distance between the tops. So first of all, we'll draw the figure. This is one pole of 6 meter. This is another pole of 11 meter height, right? And distance between their feet P and Q is given to us, that is 12 meter. We need to find this AP. Okay, so from this structure we further construct a perpendicular from A to this PQ. Okay, now we get a rectangle here, right? This is rectangle, so 12 meter, this will be 12 meter, 6 meter, this will be 6 meter. Okay, so out of 11 meter total height, 6 meter is covered in this rectangle. Remaining will be 11 minus 6, that is 5 meter. Okay, now we'll take this right triangle APC. In this triangle we need to find the hypotenuse. Both the sides, base as well as perpendicular, is given to us. Now see, by drawing the figure of the question, it becomes so easy. Now we just need to apply the Pythagoras theorem and calculate the AP. Okay, so from figure, in triangle APC, AP square is equal to AC square plus BC square. This AP square we need to find. This is equal to this square plus this square. Now solve it. AP square comes out to be, AC is 12 but PC is 5. On simplification it gives us 144 plus 25, that is 169, or AP is equal to under root 169, that is AP is equal to 13 meter. So the distance between the tops of two poles is 13 meter. Now see how easy the question becomes after the diagram. So let's take the next question. Question number 13. Here D and E are points on the sides of CA, CB respectively of triangle ABC, right angle at C. So we are given a right triangle ABC. This way, right angle at C. D and E are 2 points on AC and BC, CA or CB respectively. We need to prove that AE square is equal to BD square, AD square plus BD square is equal to AB square plus DE square. So in this triangle, let's join this A to E, B to D, and D to E as well. Okay. Now see what we need on the left hand side, AE square. AE square can be written from this triangle. This triangle involves AE square, right triangle. Okay, so in right triangle AEC, AE square comes out to be AC square plus EC square by Pythagoras theorem. Let this be our equation number 1. Similarly, we need BD square. BD is from this triangle BDC. BD square comes out to be BC square plus DC square. Again from Pythagoras, let this be our equation number 2. Now on the left hand AE square plus BD square, we will add 1 and 2. Let's see what we get on left hand side AE square plus BD square. Okay. On right hand side AC square plus EC square plus BC square plus DC square. Now here see AC square plus EC square. We'll rearrange these terms like this: AC square plus BC square, AC square BC square. In this triangle ABC, right angle at C, AC square plus BC square is equal to this AB square by Pythagoras. Okay, similarly EC square and DC square, this is also a right triangle DEC. So this is the hypotenuse DE is equal to DC square plus EC square. So EC square plus DC square is replaced by DE square, and this is replaced by AB square. We get the desired result, that is AE square plus BD square is equal to AB square plus DE square. Hence it is proved. Okay, so let's move question number 14. The perpendicular from A on side BC of a triangle ABC intersects BC at D such that DV is equal to thrice of CD, 3CD, 3 times CD. Prove that twice of AB square is equal to twice of AC square plus BC. Very important question this is also. So let's draw the diagram first. So ABC triangle, right, perpendicular from A on BC, right, such that this DB is 3 times the CD. Okay, we need to show that AB square, twice of AB square is equal to twice of AC square plus BC square. That's all. Now in right triangle ADB, this ADB and ADC, in these two triangles, AB square is equal to AD square plus DB square from PGT, Pythagoras theorem. Similarly, AC square is equal to AD square plus CD square from Pythagoras again. So let this be 1 and this is second equation. Now if we subtract equation number 2 from 1, what we get? AB minus AC, AB square minus AC square, here AD square minus AD square, this will cancel out. Okay, DB square minus CD square, we left with this DB square minus CD square, because this cancels out, AD square and minus AD square, this will cancel out. Okay, so AC square, AB square minus AC square is equal to DB square minus CD square. Now further, DB is given as that this is 3 times CD minus CD square, that is 9 CD square minus CD square, 8 CD square. Okay, 8 CD square. Now CD, if we now see, this is one part, this is 3 parts more total. If we take BC, it is 4 parts. Okay, out of 4 parts CD is 1 part, so 1 upon 4 of BC. Okay, understood this? We are given that DB is equal to 3 times CD, means total 3 CDs are here, right? And we see BC total equal parts are 4, and CD is 1 out of those 4 parts. So CD can be written as 1 upon 4 BC here. So 8 within bracket 1 upon 4 BC whole square. It comes out to be BC square upon 16, 4 fours are 16, and 8 on simplification it will give us that BC square upon 2. Okay, so AB square minus AC square is equal to BC square upon 2. Transposing 2 to this side, what we get? We get twice of AB square minus AC square is equal to BC square, or for the simplification, open the bracket, twice of AB square minus twice of AC square is equal to BC square. Shifting AC square to this side, what we need to show or prove, always keep that in mind. So it comes out 2AB square, this is transposed to this side, we get the desired result, that is twice of AB square is equal to twice of AC square plus BC square. Hence this is also proved. Okay, easy. So let's move to next question. Number 15. We are given an equilateral triangle ABC. D is a point on side BC such that BD is equal to 1/3 of BC. Similar question to the previous one, but somewhat different. Let's see how it is done. First of all, diagram. So let an equilateral triangle ABC with point D on BC such that this is equilateral triangle ABC and D is a point on BC such that this BD is equal to 1/3 of whole BC, right? We need to prove that 9AD square is equal to 7AB square. Join this, and also we'll construct a perpendicular from this. Okay, altitude from A to this. So draw AE perpendicular to BC. Now in triangle ABE, this triangle, by Pythagoras theorem we can write that AB square hypotenuse is equal to perpendicular square plus base square. Okay, again AE square from this triangle ADE, this is also right triangle, so AE square is equal to AD square minus DE square, AD square minus DE square. Replace AE square by this plus BE square as it is. Further, this DE is equal to BE minus BD. Okay, so this is replacing DE by BE minus BD. We are left with DE. Okay, BE minus BD whole square plus B square. To this we apply A minus B whole square. What we get? A square, that is BE square. Minus sign is outside the bracket, so minus BE square. Okay, plus BD square minus multiplied minus BD square minus 2AB, minus into plus, minus into minus, plus twice of BE into BD plus BE square. Again simplify it. We'll now here minus BE square plus BE square will be cancelled out, right? And we are left with this AD square. Now BD is given that it is 1 upon 3 BC. Okay, twice of BE. BE is half of BC. Altitude is also a median in equilateral triangle. Okay, so BE is half of BC and BD again 1 upon 3 BC. We are writing all in terms of BC and then simplify it, right? So we get it AD square minus 1 upon 9 BC square plus 2 cancels BC into BC square 1 upon 3 BC. Further 9 is LCM. Okay, and simplification gives us 9 AD square minus BC square plus 3 BC square upon 9 is equal to AB square. Shifting 9 to this side, we get 9 AB square is equal to 9 AD square plus twice of BC square. Now see what we need to prove. Always keep that in mind. 9 AD square. So 9 AD square, shift this to this side, we get 9 AD square is equal to 9 AB square minus 2 BC square. Now since this is a equilateral triangle, right? All the three sides are equal. So we can replace BC by AB. 9AB square minus 2AB square, that is 7AB square. This is what we need to prove. Okay, 9AD square is equal to 9AB square minus 2AB square, because all the sides are equal, and ultimately we can prove what we are asked to prove, that 9AD square is equal to 7AB square, right? So this is how this is done. So let's take last question. Again, of equilateral triangle, prove that 3 times the square of one side is equal to the 4 times the square of its altitude. Now since equilateral triangle, all the three sides are equal, all the angles are equal, okay, all the altitudes are equal, altitudes are medians also, this property should be kept in mind. So we are given, let this ABC is a triangle, equilateral triangle with altitude CD. We need to prove thrice of AC square is equal to 4 times altitude square, that is 4 CD square. So let the each side of triangle is equal to twice 2A. Then in right triangle CDA, CDA, in this triangle CDA, AC square is equal to CD square plus AD square by Pythagoras theorem, or CD square. We need to find the CD, right? CD square is equal to AC square minus thrice of AD square. AC is 2A and AD is half of this 2 is A square, which gives CD square is equal to 4A square minus A square, or CD square is equal to 3A square, right? Ultimately CD comes out as under root 3A. Altitude comes out, each altitude will be under root 3A. Further, 3 times the square of side, that is 3 into side is 2A, square of 2A is 4A square into 3, that is 12A square, and 4 times the square of altitude. Altitude comes out to under root 3A, square of under root 3A is equal to 3A square into 4, that is 4 3 is 12A square. So it comes out to be 12A square, as well as it was asked in the question to prove. So it is proved that 3 times the square of one side of an equilateral triangle is equal to the 4 times the square of its altitudes, right? So this is the last question of the exercise 6.5. If you have any doubts, any problems, any queries, please drop comment in the comment box for me, and we'll look for that. Okay, we'll work on that. Until then, as usual, keep your mind full of positive thoughts. Keep working hard. Hard work is the only key to success. Okay, so I'm leaving with this thought, but do not dwell in the past, do not dream of the future. Just concentrate on the mind, on the present moment. Okay, just live in the present. Your future will be decided by deeds in the present. Thanks for watching. Thank you.